Across continents and oceans, through storms, deserts, and vast expanses of sea, millions of birds embark on extraordinary journeys migrating thousands of miles with breathtaking precision. From the Arctic tern, which travels from the Arctic to the Antarctic and back again each year, to flocks of snow geese flying in perfect formation above towering mountain ranges. These migrations are among nature's most awe-inspiring feats. Their paths stretch over unfamiliar landscapes and treacherous environments, yet somehow, they find their way returning year after year to the very same nesting sites, sometimes thousands of miles away from where they started. What makes this even more remarkable is that many of these birds are navigating routes they've never flown before. Young birds often make their first migrations alone, without guidance, and still, they arrive at their destinations with uncanny accuracy. How do they do it? The mystery of bird navigation has fascinated scientists and nature lovers alike for centuries. And today, with climate change altering the very fabric of our planet's shifting seasons, disturbing weather patterns, and reshaping the landscapes birds depend on, understanding their navigational abilities has never been more urgent. One of the most fascinating discoveries in recent years is the role of Earth's magnetic field in guiding birds. Birds are equipped with a remarkable internal compass, thanks to a sense known as magnetoreception. This ability allows them to detect the planet's magnetic field and use it to determine direction, like an invisible map etched into their biology. Recent studies suggest that birds may actually see magnetic fields through special proteins in their eyes that respond to geomagnetic forces. These proteins may create visual cues that help the bird align itself during flight, sensing tiny variations in the field as they move across the globe. Scientists have found that this biological compass is not only precise but incredibly sensitive. In controlled experiments, birds have been observed adjusting their direction in response to manipulated magnetic fields. And as researchers continue to unravel the mechanisms behind magnetoreception, they're uncovering potential applications far beyond ornithology, new possibilities in navigation technology, biosensing devices, and even environmental monitoring tools. But this system isn't immune to disruption. Climate change may be altering the structure of Earth's magnetic field in subtle but significant ways. These changes could affect how birds perceive magnetic direction, leading to disorientation and dangerous detours during migration. But magnetic fields are just one part of the story. Birds are also celestial navigators, charting their course using the sun, the moon, and the stars. For centuries, birds have relied on the night sky as a reliable compass. Experiments have shown that migratory species orient themselves using constellations, particularly the position of Polaris, the North Star. Even on cloudy nights, many birds can detect polarized light patterns in the atmosphere to guide them. By day, they use the sun's position, adjusting their internal clock to correct for its changing position in the sky. This ancient method of navigation, however, faces a new and growing threat: light pollution. Artificial lights from cities, street lamps, and buildings drown out the stars, disorienting birds that depend on the night sky, confused and drawn toward city lights. Many birds collide with buildings or circle endlessly, wasting precious energy as urban areas expand and nights grow brighter. The sky that once guided them becomes harder to read, adding another challenge to their already perilous journeys. In addition to magnetic and celestial cues, birds also rely on visual landmarks and memory. Mountain ranges, coastlines, rivers, and even human-made structures can serve as navigational aids. These landmarks help birds adjust their course and recognize when they're nearing familiar territory. And while some birds are born with an innate sense of direction, many refine their migratory paths by learning from others. Young birds often follow older, experienced individuals during their first migrations, watching and memorizing the route. Over time, these learned behaviors become deeply embedded, passed from generation to generation. What's even more impressive is birds' ability to adapt. Climate change reshapes the world, landscapes shift, habitats disappear, and new barriers emerge. And yet, many birds adjust. Some are developing new routes. Others are altering their migration timing to match the changing climate. These adaptations showcase not only their resilience but also their intelligence. Birds learning in real time, adjusting strategies, and finding ways to survive in a world that's rapidly changing around them. Behind these remarkable feats lies a growing body of research, scientists tracking birds with satellite tags, decoding their genetics, and modeling their flight paths to understand how they make such complex decisions. What they're uncovering has far-reaching implications. Insights into bird navigation are inspiring breakthroughs in robotics and artificial intelligence, where autonomous systems could one day mimic the efficiency and precision of bird flight. Drones may one day navigate disaster zones using similar principles. But with such power comes responsibility. As we translate the secrets of nature into human technology, we must consider the ethical implications, ensuring that such knowledge is used to protect, not exploit, the natural world. Perhaps most importantly, understanding how birds navigate can help us protect them. Conservation efforts grounded in science can help preserve critical stopover points, reduce harmful light pollution, and safeguard the habitats birds depend on during their incredible journeys. As we face an uncertain environmental future, birds are more than beautiful symbols of freedom. They are vital messengers of planetary health. Their survival depends on our choices, and their migrations are a testament to the resilience of life itself. So, the next time you see a bird in flight, remember, it may be navigating thousands of miles across continents and oceans, using tools more ancient and advanced than we ever imagined. Their journeys are not just migrations, they are miracles of nature, shaped by instinct, memory, and the stars above. If we want to ensure those journeys continue for generations to come, we must do our part. Support the organizations working to protect bird habitats. Reduce light pollution where you live. Get involved in local conservation efforts, because protecting birds means protecting the world we share with them. And their flight is our future too.